All right, so limits tend to not be super difficult, especially from graphs. You just have to learn how to read the graph and read the notation. So just so you know, I'm going to write out what this notation means in English. That means the limit of the function f of x as x approaches c. And c is typically a number, a constant number. One day in this unit, we're going to talk about the limit as x approaches infinity, and we'll talk about what those mean. Okay? But when we are looking for limits, limits are y values, always. And the best way to think about them, like we talked about on our warm-up, is a prediction of a y value. The function does not always have to be established at that point. It can have a hole, it can have an asymptote, it can have other issues going on, but it's a prediction of the y value. We're going to start off with some easy ones, and you're going to be like, what the heck are we doing this for? Because these are just a line. So for some of them, you're going to know exactly what the limit is because it's the same as the function values. Just understand as we go down the page here, it's going to change a little bit, okay? So first and foremost, you need to know what x value you're talking about. So in this top left example here, we're looking for the limit of this graph, this f of x graph, as x approaches what? 1. So this is an x value that you're given. That means on this line here, I am looking at where this appears to be around 1. Okay? This specific example, does that function have an actual value at 1? Yes, it does. What is the actual value right there? 2, the y value. That is, in this case, the function value. F of 1 is equal to 2. It is also the limit. Because if I was predicting, coming in from either side here, what this function was getting closer to in the middle there, it's still 2. Those are exactly the same thing in this case. Some of them, they'll be a little different. Okay? So we're starting with easy ones. You're just predicting the y value as you're getting closer to 1. Yes, sir? Because from either side, if I was coming down that line from the top or up the line from the bottom, it's still getting closer and closer to 2. That's what the limit is. What is the actual function value on the second one? If I asked you for f of 1, it's saying exactly at 1. What is the y value? 3. 3, 2.5. Let's go with that. This one's kind of off. Just give me a good estimation. What do you think that is? 2.5. Let's go with 2.5. So you're just giving me a good estimate off the graph. The limit is a prediction of the y value. If the function actually exists there, if there is a value for that point, it can be the answer for the limit as well. It's not always, though. And you'll see that in the next the examples that are to follow down here. Even when I'm finding the limit here, I'm tracing the graph from the left and from the right and seeing what I'm getting closer and closer to in the middle. What does it get closer and closer to in the middle here? 2.5, same value. Now, the reason we talk about the limit sometimes being different from the actual function value is because of an example like the one directly below this. Yes, sir. All right, so on the left one here now, we've got another issue that's a little bit different with this one. Sometimes, like this one on the right, we have an instantaneous value where f of 1 is equal to negative 1, but we don't have a limit. Let's take a look at this one. What would you tell me f of 1 is? It's undefined on this one because it's a hole in the graph. So that instantaneous value of f of 1, exactly at 1, there is nothing there. That's what that hole means. However, even though there's nothing there, can we predict what it would be if there was something there? That's what a limit is. Okay, so that's where we follow it in from the left, follow it in from the right, and predict what it's getting closer to in the middle. What is that getting closer to? 2 or something like that. Okay? So sometimes you'll have the instantaneous value and no limit. Sometimes you will not have the instantaneous value, but you will have the limit. So they can be two different things, but we're just reading graphs here. All right, let's try the same thing. Take a minute and try the one below this one on your own. Find the limit as x approaches -2 on this one. All right, let's check these last two real quick. In this case, the instantaneous value at -2. There's a hole in the graph, therefore f of -2 doesn't exist or is undefined. On the other hand, as you follow the graph in towards x equals -2, it's approaching a value of 2. So if there was something there, we would say it would be 2. Now, on this one does not specifically have a closed dot here. But remember we said if there is no open dot like there is here, what do we assume right here? A closed dot. You may assume a closed dot right there. Therefore, my value at -2 is -2. But your limit, we have to check the left side coming in towards it and the right side coming in towards it. What's the left side approaching here? What y value? 1.8, 2. Either way, it's not the same as what it's approaching over here. What is it getting closer to here? A y value of -2. If those two sections are not approaching the same number, our limit does not exist. On page 399, we have something specifically called one-sided limits, or approaching a limit from either side. So what we do on these, just to show you some notation here, you can have it written one of two ways. The limit of f of x as x approaches c, if there's a little negative right there, that means from the left. This same notation except with a plus sign means from the right. Sometimes we use this notation in special cases where you can only approach your graph from one side. That's what you see here under A. All right? Could I find the limit as x approaches 0 from the left on this graph? No. Is there any section of the graph over here that I can follow in from the left towards 0? No. I don't have a graph over here. So in this case, you would use the limit as f of x approaches 0 from the right only, because you can only follow the graph from the right. You can't approach it from the left. You can also use it for piecewise functions. Now, for piecewise functions, you're going to want your calculators to do these, unless you really like graphing these by hand. Me? No. All right, so everyone find your calculators. We're going to practice putting in a piecewise function, that specific one right there. While some people are getting this typed in, this is another place we talk about from the left and from the right. Shh. On here, on a piecewise function, or this is what we just called a split function on the first page, this is a lot of the places we'll talk about two-sided limits, one side and then the other side. Remember we were talking about this on the first page. I told you to follow one side in towards 0, follow the other side in towards 0, and see if they're coming towards the same number. We were essentially doing one-sided limits there. So here's how you check if a split function, a piecewise function like this, has a limit. First thing you check, and I'll put the notation on here, is the limit of the function as x approaches 0 from the left. So from the left simply means, what am I doing here? I'm following this graph from the left and seeing what y value it is getting closer to. In this case, what is the limit of this function as we approach 0 from the left? -1. Any problems with that? This is just getting closer to -1 on the y-axis. Then we do the limit of the function as x approaches 0 from the right. To do that one, we simply follow the right side in. So we follow it in from the right here. Let me get a color you can see. Woo! Follow it in from the right. What is that approaching? 1. In this case, so this is what we were kind of doing mentally on the first page. We followed it in from the left, we got -1. We followed in from the right, we got +1. What does that mean about the limit as a whole? If it approaches one number from the left and a different number from the right. DNE. Does not exist. So that's kind of how you follow it through that notation. You won't always be asked to show the limit from the left and from the right, but that's kind of how we show that notation. That was just the fill-in-the-blank stuff then down underneath that function. I just wrote it on this page. Questions on that? All right. Flip to the back real quick. We're going to do this just a couple more times using our calculators. The next one has a 3-part piecewise function. So, on this one, just delete what you have. Use your templates menu and put in a 3-part piecewise function. And type that in real quick. All right, a couple things on this as you look at it. First, this had 3 pieces to it. How many pieces to your graph do you see here? Only 2. One coming in here and one coming in from the top. What is the third piece that we're missing from that?
A dot.
It's the dot. How do I know it's a dot? That middle piece says it's -7 if x equals 2. So I can draw on mine, so this is a great way to do it, but that just means at 2 specifically, I have a dot somewhere down here at -7. Of course, that's not down at -7 because I wouldn't be able to see that, but that's what it is. That changes some of my answers. So let's look at the questions this asks me. Okay? It doesn't necessarily change my limit, and it doesn't ask the specific question, but I'm about to. First, it asks us in part A, find the limit as we approach 2 from the right. So if I want to approach 2 from the right, that means I follow this right section towards 2. What y value is it getting closer to? 4. Looks about right. Then it asks me the limit as I approach 2 from the left. So we follow the left section down. As we approach 2 from the left, what does it get closer to? 4. What does that mean about the limit as a whole? It is 4. Okay, because remember, what's true? The limit can be different than the instantaneous. Okay? So this means that my limit as x approaches 2 of this function is actually 4. That's the predicted y value.
Could you see why this is like really
Yes, hang on just a second. However, if I asked you a different question, what if I ask you this question? What is f of 2? -7. The limit is different than the instantaneous value. The instantaneous value just means at 2 specifically only. What is the actual value? The limit is the rest of the graph. What is it predicting the y value to be, or what is it getting closer to? So the limit is 4. The instantaneous value is -7.